This lesson is about frequency of periodic functions. Another way of, as it says, expressing how often a periodic function repeats itself is using frequency instead of just period, which we find by dividing 1 by the period. This lets us know how often a function repeats itself per unit of time. Here's my formula, f equals 1 on t. Example 1, calculate the frequency of a periodic function which has a period of 4 seconds. That's telling me my period is 4. So my frequency would be 1 on t, which is 1 on 4. What are these units? Well, I divided by seconds, so this is really per second. So there's 1/4 of a cycle per second. What would this look like? Suppose I have just a sine graph with a period of 4. In 1 second, I've got 1/4 of a cycle. I can do a similar thing for part B, where the period is 0.2 seconds. In this case, t is 0.2. Frequency is 1 on t, or 1 on 0.2. Simplify this fraction, I'll have 5. Remember, the units are per second. What does this mean? My period of 0.2 means that this is going to repeat itself 5 times in 1 second. So if I'm using the sine graph example, we see that in 1 second we encapsulate 5 cycles. It's the whole idea of frequency. When the unit of frequency is per second, it should be written as Hertz. So now that we're adults, we won't write per second, we'll use Hertz, which is abbreviated as Hz. When you're playing a piano, the frequency, or the rate at which the strings are vibrating, for each note is given in Hertz. So on this table to the left, we've got some frequencies, got some periods. We should be able to change backwards and forwards from frequency to period using f equals 1 on t. Have a go at doing that, press pause, see how you go. There we go, we can find frequency in Hertz and period in seconds. So when these piano strings are vibrating many times per second, going through their vibration cycle lots of times per second, that's what gives them different sounds, the rate at which they vibrate, determined by how strongly tightened the string is, and its length and all these other properties. As a final example, we can calculate the hertz of electrical waves produced by certain motors or converters. We have an electrical wave here. We're asked to calculate the frequency in hertz. I'll write my formula. Frequency is 1 on the period. Since it says approximate, I'm just going to find an approximate period. So between here and about here is a period. I'm going to say that my period is 0.02. So I'll say t equals 0.002, and I'll be able to substitute this in and find my frequency of 50. Since this time is in seconds, this frequency will be in Hertz. So that's a short overview of how to calculate frequency of periodic functions.